All right, so this is a continuation of the mixture problem introduced in the first video. Here's the system of equations we came up with that represents the fact that the two quantities of salt solutions have to add up to 10 milliliters, and the 20% of one plus the 70% of the other has to add up to 50% of the 10. Now, we can simplify this a little bit. For the purposes of doing our algebra, I decided to take that second equation and multiply both sides of that equation by 10, which produces this one, which is a little bit easier to work with. 2x plus 7y equals 50. We can avoid dealing with decimals by doing this, and so now all of our coefficients for x's and y's and constants, those are all integers. So that's the one I'll be working with, attempting to solve. So first we're going to solve it by the substitution method. Substitution. Okay, the idea of the substitution method is you're going to take one of the two equations. It doesn't matter which one, just pick one of them. And then you're going to solve it for one of the variables. Again, it doesn't matter which of the two variables, you just pick one. You solve it for that variable in terms of the other. So that means you will have isolated that variable by itself on one side of the equation. Then you can use that to make a substitution in the other of the two equations. So I'll show you what I mean. I'm going to take the simpler of the two, which is x plus y equals 10. I'm going to solve for y. So I'm going to subtract the x from both sides and get y equals 10 minus x. Now, wherever I encounter a y in this problem, I can say that that has to equal 10 minus x. So in particular, I can go to the other equation, 2x plus 7y equals 50, and I can replace the y in that equation with a big blank parentheses and stick in there 10 minus x, because y equals 10 minus x according to the first equation. Remember that we're trying to satisfy both of these equations at the same time. In fact, another name for systems of equations that you'll encounter in other countries, like Britain, for example, is simultaneous equations, because we need them to be true simultaneously. But we can take advantage of that. Assuming they are both true simultaneously, we can then deduce what the x and y values have to be. That's what we're doing here. We're taking this equation for granted, saying that y has to be 10 minus x, and then using that in the second equation. So now what we've done is we have produced an equation which no longer has two variables in it. By doing this substitution, we've narrowed this down to an equation of one variable. Now that is something that we know how to solve. We practiced that a bunch of times in chapter 2. This is not only is this just a system, an equation of one variable, it's a linear equation of one variable, so super easy. So the first thing I want to do to solve this is just go ahead and distribute that multiplication by 7 here. So we're going to have 2x plus 70 minus 7x equals 50. And then I guess let's just perform the combination of the x's, and let's go ahead and subtract the 70 from both sides. So we're going to have 2 minus 7 is negative 5x. And then on the right, 50 minus 70 would be negative 20. Divide both sides by negative 5, and we've got x is going to be 4. Now we have one of the two variable values for the variables. What we're going to do is take that in combination with the this step back here. We're going to take the y equals 10 minus x, stick the 4 in for x, and get our other value. So y equals 6. So that means that a solution to this equation is x value 4, y value 6. You can represent that as an ordered pair like that, as if it were a point. But the real solution to this, the actual solution to this problem, it has to do with what was originally being asked. So recall, we were asking about salt solutions and how many milliliters of each solution we should combine to achieve 10 milliliters of a 50% solution. And we said x was going to be the milliliters of the 20% solution, and y was going to be milliliters of the 70% solution. So looking back at that information, we can write down our answer in the context, which is that we should combine 4 milliliters of the 20% solution with 6 milliliters of the 70% solution. And that's the real answer here, the one that answers the question we had originally posed. Whenever you're dealing with some kind of application problem like this, you should always take your solution and put it back into the context of the problem and give an answer which uses units and references the information that you were given originally. Okay, so that's first strategy for solving an equation like this by substitution. In the next video, we're going to do it by the other method.